This is Algebra 2, Unit 8, Lesson 7, more work with the quadratic formula. Now, in the last lesson, we went over the quadratic formula again, and it's right here. We can see x equals negative b plus or minus the square root of b squared minus 4acl over 2a. Now, remember, it's extremely useful because it allows us to solve quadratic equations, whether they are prime or factorable. So it can be used for any quadratic equation. So we're going to get some more practice using this formula in this lesson. All right, let's consider the quadratic function f of x equals x squared minus 4x minus 36. Algebraically, determine the function's x-intercepts using the quadratic formula. Express your answers in the simplest radical form. Okay, now notice here this says simplest radical form, so probably this tells us it's not going to factor. All right, now the next thing we need to know is where are the x-intercepts? Well, when we talk about x-intercepts, that's where it crosses, the parabola crosses the x-axis. What do we know about the coordinates? At the x-intercepts, the y is always going to equal 0. So if I take this equation and plug in y equals 0 right here, I will find the x-intercepts, because that's where y equals 0. Now, since we know this says simplest radical form and it says to use the quadratic formula, we have to know what our a, b, and c values are. All right, now recall that the a value is in front of the x squared, so a is going to be 1. The b value is in front of the x, so that's going to be negative 4. And the c value is going to be the constant value, which is negative 36. Okay, so following your formula, x equals negative b. Well, since this is negative 4, it's going to be positive 4. Plus or minus the square root of b squared, put it in parentheses, negative 4 squared, minus 4 times a is 1, times c is negative 36, all over 2a, which would be 2 times 1. So I plugged all these in. Now I can put everything that's underneath the radical in my calculator, which I'm going to do. All right, there's my square root. Go into my calculator, parenthesis, negative 4, close your parentheses, squared, minus 4 times 1 times negative 36. Close your parentheses. Now notice that looks exactly like what's on my paper, parentheses and all. And I get 160. All right, so this is going to be 4 plus or minus the square root of 160, all over 2. All right, now I need to simplify the square root of 160. Well, 160, what perfect square goes into that? It would be 16 times 10. That's the biggest perfect square that goes into 160. 16 is 4. Square root of 16 is 4. So this is going to be x equals 4 plus or minus 4 times the square root of 10, all over 2. Now, when I simplify this, remember that this 2 is dividing both of these terms. I like to split it into separate fractions so I know what I'm dividing. And notice it can only divide the rational number out front, because irrational and rationals can't divide each other. So 4 over 2 is 2, plus or minus 2 radical 10. All right, so those are the x-intercepts. Now, if I want to do this, the intercepts on the graph, it's helpful to know where the values are. Express the x-intercepts of the quadratic to the nearest hundredth. Now remember, this actually is 2 intercepts. X equals 2 plus or minus 2 radical 10 actually means x equals 2 plus 2 radical 10 and x equals 2 minus 2 radical 10. All right, so what you do is you put this part in your calculator. 2 plus 2 times the square root of 10. And rounded to the nearest hundredth, this would be 8.32. So flip back here, x is going to be 8.32 approximately. Okay, 2 minus 2 radical 10. To save myself some time, I'm just going to arrow up and grab this, so I don't have to retype it. You can retype it if you want to. And then I'm going to arrow back and change the plus to a minus. 2 minus 2 radical 10. All right, and that comes out to be negative 4.32. So x is approximately negative 4.32. Okay, now for part C, it says using your calculator, sketch a graph of the quadratic on the axes given. All right, and then we're going to verify the zeros and using the calculator. But we're not going to use the 0 command. We're going to use the intercept command, but I'll explain that in a minute. All right, so first of all, let's take the equation, x squared minus 4x minus 36, and we're going to put it into our graph. So x squared minus 4x minus 36. Okay, so we did that. Now we want to set our window to match what's on our paper. So if we look at our paper here, x is from negative 20 to positive 20, and y is from negative 50 to positive 50. So let's reset our window so it looks like what's on the paper. So x is from negative 20 to positive 20, and y is from negative 50 to positive 50. So that'll fit on my graph, and it'll look like it's on my paper. All right, so if I hit graph here, I have my axes on so I can, or my graph on so we can see it. All right, so that looks like it's going to be like that. So let's sketch our graph. It's going to look something like this. Doesn't have to be perfect, but close enough. All right, now, there's my graph. Now, I'm looking at the x-intercepts right here. Now, on the graph, if we did this correctly, this should be negative 4.32, and this one should be 8.32. All right, and let's check and make sure they are. Now, you can use the 0 key, but I don't like using the 0 key because it can be kind of awkward. I like to use the intersect key. Now, remember, we said on the x-axis, the y values are going to equal 0. So what we're going to do in the second line, you're going to put y equals 0. All right, when I graph that, I get the blue line is the parabola, the red line is the x-axis. So I want to do the intersect of those. So I press second, trace key. I'm going to pick number 5 for intersect. All right, now remember when you're doing an intersect, you're telling it what ones you're looking at intersect. So first curve means the blue one. Yeah, I'm going to use that one. Second curve is the red one. Yep, I'm going to use that one. And I'm looking for where they intersect is the guess. Now this is where you want to tell. There's 2 intersects here, so I want to tell the calculator which one to use. So you move your cursor close to the one you want to find. So it doesn't have to be right on it, just close to it. All right, it'll go to the closest intersect. So right there is good. See the cursor moved? Press enter again. Look at that, negative 4.32. That's what we found for the one. All right, let's do the other one. Second intersect for number 5. I want to use the first curve, the blue one, yes. Second curve, the red one, yes. And now for the guess is where I move it close to where I want it. I'm looking for the other intersection. Which would be, that's close enough, enter, 8.32. So I verified that those are the correct values. We found it. So this is negative 4.32 and this is 8.32. So those are the rounded approximate values. The actual values, this one would be 2 minus 2 radical 10, and this one would be 2 plus 2 radical 10. All right. All right, so let's try this next one. Which of the following sets represents the x-intercepts of y equals 3x squared minus 19x plus 36 plus 6? Okay, so notice on here, there's a couple of these that are rational and there's a couple of these that are irrational because of the square root. That tells me that I probably want to use the quadratic formula to make sure because it may or may not factor. We don't know. All right, so if y equals this, if x-intercepts, y is going to equal 0. 3x squared minus 19x plus 6 equals 0. All right, my a value is going to be 3, b is going to be negative 19, and c is going to be 6. So using the quadratic formula, negative b would be 19, plus or minus the square root of b squared would be negative 19 squared, minus 4 times 3 times 6. 4 times a times c, all over 2a would be 2 times 3. 19 plus or minus, I'm going to put this in my calculator, parentheses and all, parenthesis, negative 19 squared minus 4 times 3 times 6. And that gives you 289. All over 6. Okay, well, I happen to know that the square root of 289 is 17. It's a perfect square. So this is 19 plus or minus 17 over 6. So since 289 is a perfect square, that immediately eliminates these two right here. So it's either going to be this one or this one. All right, now remember, this is 2 different answers. This is 19 plus 17 over 6. and this is 19 minus 17 over 6. Well, 19 plus 17 is 36 over 6, which is 6. And 19 minus 17 is 2 over 6, which is 1/3. So your answer is x equals 6 and x equals 1/3. That means it's number 4. Okay, for exercise 3, this one is talking about looking at the Crazy Caramel Popcorn Company again. I'm going to save this one for class the next day. We'll go over it together. All right, but I do want to do number 4 together. All right, find the intersection points of the linear quadratic system shown below algebraically. Okay, so if I want to do this algebraically, we are looking for how to solve this. You want to use your calculator to prove a sketch and label the intersection point on the graph. Okay, y equals 4x squared minus 6x plus 2, and y equals 6x minus 3. If we want to solve this algebraically, we're looking for where the two graphs intersect. So they would be equal to each other. Y is equal to, so they'd be equal to each other. So 4x squared minus 6x plus 2 is equal to 6x minus 3. All right, reminder with the quadratic equation, it's got a square root in it. It has to be equal to 0 before you can do anything else. So I'm going to move these over, minus the 6x and plus the 3, which gives me 4x squared minus 12x plus 5 equals 0. Okay, now we can factor this, or we can use the quadratic formula. I don't know if this factors or not, so I'm going to use the quadratic formula. X equals, all right, I need my A, B, and C. A is going to be 4, B is negative 12, C is 5. So negative B, B is negative 12, so negative B would be 12, plus or minus. B squared would be negative 12 squared, minus 4 times A is 4, times C is 5, all over 2 times 4. Okay, X equals 12 plus or minus. I'm going to put this in my calculator. Negative 12 squared minus 4 times 4 times 5, which is 64, all over 8. All right, 64 is the perfect square. 12 plus or minus the square root of 64 is 8, all over 8. Okay, now remember, this is two answers. 12 plus 8 over 8, and 12 minus 8 over 8. All right, so 12 plus 8 is 20 over 8, which is 5/4, or 5/2, excuse me, which is 2.5. So that one's 2.5. And 12 minus 8 is 4 over 8, which is 1/2, or so x is equal to 0.5. All right, so that tells me that my two x values are going to be 2.5 and 0.5. Now remember, if I'm looking for where they intersect, I should also have a y value. All right, so if x equals 2.5, what y value goes with it? Well, I would plug it into one of these. I'm going to use this one because it's easy. 6 times 2.5 minus 3. 6 times 2.5 minus 3. 6 times 2.5 minus 3 is 12. So y is going to equal 12. So 2.5, 12 will be one point of intersection. And for x equals 0.5, 6 times 0.5 minus 3. 6 times 0.5 is 3 minus 3 is 0. So my other point is going to be at 0.50. All right, so let's graph these and see if we're right. All right, so we'll do the graph in class to make sure that we have it, and we'll do the other problem on the next class.